This is your video for Accentuate the Negative 1.4. This is video number 2 for Investigation 1.4, where we will continue using the colored chip model in order to demonstrate subtraction of integers. I'm going to continue with black chips representing positive and red chips representing negative. If you used two different colors in the previous video, I encourage you to continue with those same colors, both for these notes and in class, so that you are consistent and you don't cause yourself confusion by constantly switching colors. So we are going to start with subtracting integers with the same sign. We'll start easy and then we'll start to mix things in. So the first problem I have is 4 minus 3. Both of those values are positive. So I'm going to start by having 4 black chips on my board. And with subtraction, I'm going to cross out what I don't need. So because I am taking away or don't need 3 of them, I'm going to X them out. That leaves me with 1 left over, and it's black, so it's positive. So I have a positive 1. Next, I have a positive 6 minus a positive 2. So I'm going to put 6 black chips on my board. And I'm going to take away or cross off 2 of them, showing my representation that there are 4 left, and because they are black, that I have a positive 4. Now the next one gets a little more interesting because I have a 6 minus 7, so I actually need to take away more than what I start with. So I'm going to show you how that works. I'm going to start with my original 6 black positive chips. Now, the model needs to show a way to be able to take away 7 but not change the original value of having 6 chips. The way to do that is to actually add a pair of opposites, because opposites, one positive and one negative, actually is equal to 0. So it does not change the original value of the original 6 that I put on the board. Now I can go through and I can cross off 1, 2, 3, 4, 5, 6, 7. I have the ability now to cross off 7 black chips. The only thing that is not crossed off is a red, and there is one of them, so I have a negative 1, since red equals negative. See if you can show 5 minus 8 modeling the way I did 6 minus 7. Pause the video. When you come back, you'll see my answer. So the first thing that you got to do is put your original 5 positives on the board. But because we need to be able to take away 8, I actually need to add 3 sets of opposites. So I add 3 sets of a black and a red, because those technically equal 0. So I have not changed the amount that I have on the board, but it does give me the additional black chips that I need to be able to cross off. So now I can start Xing out my 8. This would be 5, 6, 7, 8. So all my blacks are gone. It gives me 3 reds left over, because 3 are negative. My final answer of 5 minus 8 is negative 3. See if you can do 4 minus 10 completely on your own. All right, so the chip model shows that I had my original 4 that were put on the board right here. But then, in order to be able to take away 10, I had to add an additional grouping of my positive and negatives. That's what that area is right there. But of course, I'm only going to take away the black because I only want to take away the positives. That then leaves me with the 6 red left over, showing a -6. All right, the next one is different because now I have a -2 minus a -3. So because these are both negative, they're still the same sign. I now need to start with my red dot. So I have 1, 2. Those are my original 2 negatives. And similar to when we needed to take away more black, I need to be able to take away more red. In order to take away more red, I have to add sets again of opposites, 1 black with 1 red. By adding 1 set of a red with a black chip, I can now take away 3 negatives by crossing them off. 1, 2, 3. That's opposite of the previous problems, but it leaves me with 1 black, which means my answer is a positive 1. Let's look at another problem like that. I have a -4 minus a -3. So because I'm starting with negatives, I need to put 4 negative chips on the board. Now I need to take away 3 of those. So because I have enough, I started with 4 and I only need to take away 3, there's enough on the board, I can just start crossing them off. 1, 2, 3. What does that leave me with? 1 red chip, so a final answer of -1. Let's keep going. -1 minus a -3. All right, there I start with my -1, but I need to be able to cross off 3 of them, which means I need to add extra sets of positive and negative. So now that I see that I have 3 negative chips on the board, because that's how many I need to take away, I can start to do my subtraction. Since I need to take away 3, 1, 2, 3, the board shows me that I have 2 black chips left, and because black is positive, I have a positive 2. Let's do the last one. -3 minus a -1. So let's put our 3 negatives on the board. And since I only need to take away 1 of them, I do not need to add sets of opposites. I've taken 1 away. That leaves me with 2 red chips left. Red is negative, so I have a -2. Let's look at what happens when we add with different signs now. So subtracting integers with different signs. Once again, we're going to use the black and the red chip model. I'm starting with a -4. So I need to start by putting 4 red chips on the board for negative. And I need to take away, that's what subtraction means, I need to take away 2 positives. This is a positive. So I need to take 2 of those away. I don't see positives on my board. I only have 4 red. Because red is negative, I can't take any of those away because I have to be able to take away black. because black is positive. The way to do that is to once again add my sets of opposites. So a black with a red. Then I would have to do that again, where I would have to add another set of opposites, with a black and a red. Alright, so if I'm going to take away two positives, I have to take away the two blacks. Those are gone. What that leaves me with is 6 reds. Because reds are negative, I have a negative 6. Let's go on to the next one. -1 minus 5. Again, -1, I need to start by having a negative chip on the board. I need to be able to take away 5, but that 5 is positive. So I need to somehow get 5 positive chips on my board. I'm going to do that by adding in my sets of opposites. I'm going to try and save time by putting them all on together. Alright, so there are my 5 sets of opposites. Now I have enough to start crossing off. Because I need to get rid of my 5 positives, these black chips go away. What that leaves me with are all reds, and there are 6 of them, which means there is a -6. So different problem, but actually ending up with the same answer as the first one. Alright, in the next one I have a 6, so that's positive, so I need to start with 6 black chips. And I need to be able to take away 3 negatives, which means I don't have red, so I need to add 3 sets of opposites, so I actually am not changing the original value. Alright, now that I have that, I have what on the board to take away my 3 negatives. Those are gone. That means all these black chips are left, which gives me 9 black chips, or +9. Alright, I'm going to go ahead, let you pause the video. Please draw in your chip model for the remaining questions that are left. Once you hit play, you will see my chip models drawn out, as well as what your final answer should be. Alright, so that finishes off the rest. Hopefully the chip model is beginning to make a little bit more sense and you can visualize why at times the negative is actually increasing. Say in an example like -8 minus 2, when you feel like maybe that number should go down, you can see how those red chips are increasing. We're going to look at another way of modeling this and helping to understand adding and subtracting of positive and negative numbers in class using a number line approach. One thing I want you to consider is this last question as far as what you are observing when you are adding and subtracting with positive and negative numbers, and ways that you might be able to determine if your final answer would be positive or negative.